Our session is the first of two on financial math. We'll have to get through this math before coming back to investment and financing decisions. We cover three topics in this session. The first is the time value of money, or indeed the time value of anything. The second is the concept of future value and how future value is determined by interest accumulation. And the third is the concept of present value and how present value is determined by discounting. Because investment and financing decisions have implications for cash flows that last several years, we must consider the time value of money. The value of money depends on timing or on when you receive it. In fact, the value of anything depends on when you receive it. That's because while money isn't everything, it can be exchanged for everything. A little financial economics joke for you. There are three reasons for the time value of money. The first is inflation, or rising prices over time. Because of inflation, the purchasing value of the dollar is lower a year from now than it is right now. Therefore, people will prefer to receive $100 today over $100 a year from now, because if they have $100 today, it will buy more for them. Let's eliminate inflation as an essential reason for the time value of money for right now. We're going to come back to inflation and use it in our capital expenditure analyses later on, because we're going to need to reflect inflation accurately in those analyses. But for right now, I want to concentrate on the two substantial reasons for the time value of money. One substantial reason for the time value of money is the opportunity for investment. This is the easiest explanation for the time value of money. If you have $100 now, you can invest that money in a safe asset and maybe have $105 a year from now. Hence, you would naturally prefer to have the $100 now over the $100 a year from now. Another substantial reason for the time value of money is the time preference for consumption. This is a less obvious reason for the time value of money, or less obvious explanation. But most people prefer consumption now to consumption in the future. That is, most people would prefer to have an ice cream cone now over an ice cream cone in the future, or to have a new car now over a new car in the future. The idea of the time preference for consumption is simply that people prefer to enjoy life in the current period over life in some future period. The time preference for consumption is actually the inverse of the willingness to postpone gratification, which is the same idea as your willingness to invest. You can think of investment as postponed consumption. Just as an aside, there's a relationship between age and the time preference for consumption, or the willingness to postpone gratification, where the very young and the very old are less willing to postpone gratification, that is, to invest, than are people in the middle years of their lives. So you can think of us as being people in the middle years of our lives. We're at a stage in life where we're willing to make investments or postpone gratification in the hopes of having some future where we either have more wealth or a greater ability to consume. As evidence of the notion of our willingness to postpone gratification, just think of what's happening to you right now. You're sitting at your desks and you're listening to me spout off. You could be, while you could be on the beach or on the ski slopes or in some other way enjoying life more than you probably are right now. And what you're doing is making an investment in your future by pursuing this course and your master's degree in the hopes that your wealth or your consumption abilities will be increased in the future. Much of this course involves moving money across time. To help us think about how to move money across time, we use the concepts present and future value. Future value is the amount to which an investment will grow after earning interest, and is determined by the process of interest accumulation. Present value is the value today of some future dollar amount or future cash flow, and present value is determined by the process of discounting. Let's start with future value and interest accumulation, because these concepts are perhaps the most familiar to you. Here we have our first important financial math equation. The expression is future value is equal to present value times 1 plus r raised to the power of t, where r is the interest rate. The notion here is that we want to determine the value in the future of some investment we make now if we can earn a particular interest rate on that investment. And we can determine that future value by using this equation. As an example, let's say we have $3,000 that we can invest right now at 8%. What will be the value of this investment 1 year from now? We have three parameters that we can put into our future value equation. We have the present value of $3,000, we have the interest rate of 8%, and we have the term of the investment of 1 year. Inserting these parameters into the future value equation, we get the future value is equal to $3,000 times 1.08 raised to the power of 1. And that equals $3,240. So what we have here is that just the math associated with taking $3,000, investing it at 8%, and having $3,240 at the end of 1 year. It's a very familiar process to you in terms of what you might have been doing in your own financial lives in the past. The future value formula allows us to take some present dollar amount of investment and determine what its value will be in the future. Present value and discounting actually is the opposite process. What we want to determine is the value in the present of some future dollar amount that we might receive. Now, if we solve the future value formula for present value, we get the second important financial equation of this course, which is the present value equation. Present value is equal to future value times 1 divided by 1 plus r, all raised to the power of t, where r again is a discount rate, which is very similar to an interest rate, and let's just kind of use those terms interchangeably right now. And now we have a new expression, 1 divided by 1 plus r to the t, which is called the discount factor. Now let's see how we can use this present value and discounting process. Suppose that we have the opportunity to receive $100 a year from now, and that our interest rate or discount rate is 12%. So once again, we have three parameters that we're now going to put into the present value equation. The parameters are the future value of $100 in 1 year, the interest or discount rate of 12%, and once again, a term of 1 year. Inserting these parameters into the present value formula, we get present value is equal to 100 times 1 divided by 1.12 raised to the power of 1, or $89.29. So we have the opportunity to receive $100 a year from now having actually a value to us in the present of $89.29. One interpretation of this relationship is that if we can earn 12% on our investments, or if we have a time preference for consumption of 12%, we are indifferent between getting $89.29 immediately and getting $100 1 year from now. Note that this indifference between $89.29 right now and $100 a year from now is due completely to the notion of the time value of money, or the fact that money is more valuable now than it is in the future. Hence, if we're going to postpone receipt of money, we're going to want more money in the future than we have right now. There are several ways to calculate present value. One is longhand. We represented the longhand calculation of present value in the previous slide. Calculating present values longhand takes time, and our present value calculations are going to get quite complicated as we move to investment decisions which are more realistic later on in the course. A shorthand way to calculate present value is to use a present value table. Here is a present value table. Notice at the top, the title of the table is the present value of $1 to be received after T periods, and then the expression for present value that we saw in a previous slide is given. The table is arranged with rows indicating the number of periods or the terms of the, let's say, the investment or the present value calculation. And then columns indicating the interest rate or discount rate to be applied in the present value calculation. In our example on the previous slide, we were considering a present value calculation where the period was 1 year. So we'll look at the 1 year row, and where the discount rate was 12%, so we'll look at the 12% column, and the cell that corresponds to a 12% discount rate and a period of 1 year has a value of 0.8929. To use the present value table, we take the present value factor. This is actually the discount factor, which is 1 divided by 1 plus r to the t. We take the discount factor and multiply that by our future value amount to get the present value equivalent. Now I'll just do that as an example on this Excel sheet. So our future value amount is $100, and we're going to multiply that by our discount factor of 0.8929, and we get our $89.29 as our present value. Third way to calculate present value is to use a calculator that has financial functions. Now, I'll bet several of you have financial functions calculators with little function keys on there that you probably never used. You might look at your calculators if you still have them. There might be a key that says PV, or a key that says %I, or a key that says T. And those are all the keys that would be used to key in the parameters that we've been discussing in the present value calculation. I actually never use a financial functions calculator anymore, because almost all of the financial functions calculations that I do now are in Excel. And the financial function to use in Excel is the NPV function. So let's again scoot over to our Excel file and see how we would use this financial function to calculate present value. I've labeled this spreadsheet present value 1 year. And I've already entered the parameter values for the present value calculation that we want to do. The discount rate is 12%. The term is 1 year. And the future value of cash flows in 1 year is $100. To use Excel and the net present value formula in Excel to calculate present value, what you want to do is to set up a part of your spreadsheet that shows the sequence of cash flows over time. The first column is labeled year end, and it indicates the year or the time period that is of interest. In this case, we have a 1 year time period, so we're going to have year end 0 and year end 1 in our column. The next column shows the cash flows in each one of these years. In our present value calculation that we're interested in, we have no cash flowing in year 0, and we have $100 flowing in year 1. So here's our sequence of cash flows over time. Now we want to calculate the present value of getting $100 1 year from now. Notice that I've already done the calculation and determined that the present value is $89.29 using the net present value function in Excel. But I'm going to delete that calculation now and redo it so you can see how to use the NPV function in Excel to calculate a present value. First, we highlight the cell where we want the present value to show. Then we go up to the function box, the insert function box, and click F sub X, and we get the insert function facility here. And what you see displayed is a list of functions that Excel will perform for you. The one we want right now is the NPV function, which, as you can see, says that it returns the net present value of an investment based on a discount rate and a series of future payments and income. So that is the function we want. So I'm going to click OK now to get the function arguments for the NPV function that we need to use. We need to, in order to calculate present value using the NPV function, we need to insert the discount rate and the cash flow values. Okay, the discount rate, to insert the discount rate, I click this box, and then I go over to our cell where we have the discount rate already entered, and left click that box. So by doing so, we have entered whatever's in cell B2 as our discount rate. Now for the cash values, cash flow values, I'm going to click down to the value 1 box and then scoot over to the cash flows in our cash flow spreadsheet. Click that cell, which is cell B8. So the NPV function is reading that we want to discount the value in cell B8 at the rate B2 to determine our present value. So we've got the arguments we need in the NPV calculation. I'm going to say OK. And what we get is our present value using the NPV function in Excel. As an aside, I want to mention one more way to calculate present values, which is to use the financial functions calculator watch. Some people call these watches nerd decoder watches. As a financial nerd, I used to have a financial functions calculator watch. In fact, I wore out that watch and purchased a replacement, which I also wore out, and then attempted to replace it as well. But I couldn't find a financial functions watch to buy a third time. So I asked my students over the years to try to find a financial functions calculator watch for me. I had students sending envoys to Japan, to Casio, to try to find one. I had students searching the streets of New York, patrolling the streets, trying to find one from somebody with a trench coat. I even had a student who was friends of the Walton family and had Mrs. Walton, that is Sam's wife, go into the Walmart warehouses looking for the watch. Nobody could find a watch for me, and it turned out that Casio probably only made two. It was a very limited market. So using a financial functions calculator watch is probably not a way that you're going to be calculating present values in this course. Indeed, I would suggest that using the financial function NPV in Excel is the only way that you're going to be calculating present values in the course. Just as a way of kind of reinforcing what we've learned in this session, let's go back to future value and interest accumulation and answer the question, what is the value in 1 year of our $89.29 if we invested at 12%? So what we're doing with this example is taking the present value that we calculated in the present value calculation and investing it at 12% to see what we get in a year. So our three parameters are a present value of $89.29, an interest rate of 12%, and a term of 1 year. So our future value calculation is $89.29 times 1.12 raised to the 1 power, and that equals $100. And the note here is that you can see that interest accumulation and discounting are both conceptually and mathematically inverse processes of each other. So if we have a present value of $89.29 invested at 12%, we're going to have a future value of $100. Or, contrarily, if we have $100 in future value and we discount that at 12%, we arrive at a present value of $89.29. Before ending this session, I want to show how to use Excel to calculate a future value using the interest accumulation process. I've labeled this spreadsheet interest accumulation 1 year. And the first thing I did in this spreadsheet was to enter the parameters for the future value calculation that we dealt with earlier in the session. In that calculation, we had a present value amount of $3,000, an interest rate of 8%, and a term of 1 year. So once again, we put our parameters up in the northwest corner of the spreadsheet. Now I've already calculated the future value of $3,240, and I want to show you how to do that calculation now. So I'm going to delete this calculation and then show you how to make a formula for the future value. I don't use a built-in financial function to calculate future value. Rather, I always create the formula myself. So to create this formula, we say, first key we hit is equals to let Excel know that we're creating a formula or an equation that we want to solve. Okay? Now the future value formula is equal to the present value, so I'm going to highlight the amount $3,000 or the cell that includes $3,000 to show the present value. And the rest of the formula is we take the present value times, open parentheses, 1 plus the interest rate, highlight the cell with the interest rate in it, close the parentheses, and then we hit the caret key, which is above the number 6 on the keyboard, and then highlight the cell that has the term of 1 year in it. And what we've done is to type out our future value formula. I think I can just hit enter now, and we'll get our future value calculation. Let me do that process one more time, but this time using the parameters that we looked at in the very last slide. In the very last slide, we had a present value that we calculated, or that we used in our present value calculation, of $89.29. We had an interest or discount rate of 12%, and we had a term of 1 year. Okay? So now we want to calculate the present value of $89. I'm sorry, we want to calculate the future value of $89.29 invested at 12% in 1 year. Okay, so once again, I'm going to make up a future value formula. I say equals so the computer knows that I'm doing an equation. The first term is the present value, or the amount we're investing, times, open parentheses, 1 plus our interest rate, close the parentheses, raised to the power of the number of years we're discounting, and we say, okay, and there's our $100 future value.